In this problem, I have a series of asteroids that can collide with each other. The array asteroids contains integer values representing the size or magnitude and direction of movement of the asteroids. A positive number indicates the asteroid is moving to the right, while a negative number indicates it is moving to the left. All asteroids move at the same speed. If the asteroids have the same sign, they are moving in the same direction and will not collide. If two asteroids with different signs collide, the smaller one explodes. If two asteroids with the same magnitude but different signs collide, both will explode. My task is to determine the state of the asteroids after all collisions. To understand the solution algorithm, let's take an example. For asteroids equals 5, 10, minus 5, 8, minus 8, 9, 6, minus 4, and minus 3, the asteroid 5 is positive, so it is added to the stack, resulting in stack response equals 5. Next, 10 is also positive and is added to the stack, resulting in stack response equals 5, 10. When minus 5 is encountered, I check the top of the stack. Since 10 is positive and greater than minus 5, the stack remains unchanged. Then, 8 is positive and is added to the stack, resulting in stack response equals 5, 10, and 8. When minus 8 is encountered, I find that 8 is positive and equal to minus 8, so both are removed from the stack, leaving stack response equals 5 and 10 again. The asteroid 9 is positive and is added to the stack, resulting in stack response equals 5, 10, and 9. Similarly, 6 is positive and is added to the stack, resulting in stack response equals 5, 10, 9, and 6. When minus 4 is encountered, I see that 6 is positive and greater than minus 4, so the stack remains unchanged. Finally, when minus 3 is encountered, 6 is positive and greater than minus 3, so the stack again remains unchanged. The final result is stack response equals 5, 10, 9, and 6. I will use a stack to implement this solution. A stack is a linear data structure that follows LIFO, last in, first out, allowing me to efficiently manage the insertion and removal of elements. Here is the step-by-step approach. First, I prepare an empty stack named stack response to store the remaining asteroids after all collisions. This stack will help efficiently manage the collisions by keeping track of the asteroids. As I traverse each asteroid in the array, I use a loop to go through each asteroid. If the current asteroid is positive, it means it is moving to the right and cannot collide with any asteroid already in the stack, so I add it directly to stack response. This ensures that all right-moving asteroids are properly stored without any immediate collisions. When I encounter a negative asteroid, I handle the collisions by checking the top asteroid in the stack. If the top asteroid is positive and smaller in magnitude than the negative asteroid, I remove the top asteroid from the stack. This process continues until I find an asteroid that is larger or the stack becomes empty. If the top asteroid in the stack has the same magnitude but opposite sign, both asteroids are removed. If the stack is empty or the top asteroid is also moving left, I add the negative asteroid to the stack. This step ensures that only the surviving asteroids are kept in the stack. Once all asteroids have been processed, I initialize an empty array named result to store the final state of the asteroids. I transfer elements from the stack to this array, which collects the remaining asteroids in reverse order. Since the stack operates in LIFO order, the elements need to be reversed to reflect the correct sequence. Finally, after traversing and reversing the elements, I return the result array as the final answer. This array represents the state of the asteroids after all possible collisions have occurred. In conclusion, I use the stack to efficiently manage the collisions between asteroids, ensuring the correct order of the remaining asteroids. This approach simplifies the logic and meets the requirements of the problem. Now, let's test this code to ensure it works as expected before submitting it. Remember to explore different algorithms and implementations to potentially find a more efficient solution.